on further towards the associative property for the rational numbers. I hope the associative property on the whole numbers and on the integers are all clear to you. So on the same note, we'll do the associative property on the rational numbers for the other basic 4 operations. First of all, let me recall that the rational numbers are nothing but represented by capital Q, and it involves a number which are of the form P by Q such that P and Q belongs to the integers, that P and Q are any integers with the condition that Q cannot be 0, means denominator cannot be 0 in case of the rational numbers which are of the form P by Q. So for an instance, we are talking about the associative property on the rational numbers for addition first. So let us suppose we are taking any particular 3 rational numbers out of this particular collection. So let us suppose I am taking 1 by 2, 1 by 3 and 1 by 4. So for the first addition operation, we have to prove that whether addition on the rational numbers, they are associative or not. So let's just start with it. First of all, we have to show that for any 3 rational numbers A, B and C, A plus B plus C should be equal to A plus B plus C. This is the particular condition for the associative property. It means that if any 3 rational numbers A, B and C satisfies this particular condition, it shows that the particular 3 numbers, that is the rational numbers, are associative for the addition. So let's just start with it. First of all, we have to add half 1 by 3 and 1 by 4 in this particular manner. So let us suppose first of all I am adding 1 by 3 and 1 by 4 first within the bracket and 1 by 2 outside, and for the second case I am taking 1 by 2 and 1 by 3 in a particular bracket and 1 by 4 outside. So first of all, this one is the first condition and this one is the second condition, let us suppose, and we have to show that both of them are equal to each other. So let's solve the first equation first. So this is nothing but half plus of, within bracket we have 2 fractions, that is 1 by 3 plus 1 by 4. So let's just take an LCM first. The LCM of 3 and 4 is nothing but 12. The LCM of 3 and 4 is nothing but 12. So this is 12. LCM of 3 and 4 is nothing but 12. So 3 and 12, it means 3 4s are 12. So 4 get multiplied with the numerator. So 4 into 1 is nothing but 4 plus of 4 3s are 12. So 3 get multiplied with the numerator, that is 3 into 1, which is nothing but 3. So after solving this, I'll get the answer as half plus of 4 plus 3 is nothing but 7. So this is 7 divided by 12. So I have the particular fractions as half plus 7 by 12 at the end. So let us suppose I am solving half plus 7 by 12 again. So half plus 7 by 12 is nothing but the LCM of 2 and 12 is again 12. So 2 6 is 12 plus 7. So 6 plus 7 is nothing but 13. So this is 13 by 12. It means that the value of the equation number 1 or the value of this particular case, that is the first case, is nothing but 13 upon 12. So on the same note, we'll solve the second particular case in which half plus 1 by 3 are in the first bracket and 1 by 4 is outside of it. So let's just solve this. First of all, half plus 1 by 3. The LCM of 2 and 3 is nothing but 6. So this is 3 plus 2 plus of 1 by 4. So let's just solve the particular fraction which is in the bracket first. 3 plus 2 is nothing but 5. So this is 5 by 6 plus of 1 by 4. So now we have to take the LCM of 6 and 4. So let us suppose I am taking the LCM of 6 and 4 over here. 4 and 6, let us suppose we are taking. So this is 2 3s is 6, 2 2s is 4, 3 1s is 3 and 2. So 2 1s is 2. So the LCM of 6 and 4 is nothing but 4 into 3, that is nothing but 12. So again, 6 and 4's LCM is nothing but 12. So we get 6 2s are 12 means 10 plus 4 3s are 12 means 3. So the answer is 13 by 12. So at the end, what is the conclusion? That the first case, which is half plus 1 by 3 plus 1 by 4 is nothing but is equal to the second case, which is half plus 1 by 3 plus 1 by 4, means the answer of both of these cases are same, which is 13 by 12 and 13 by 12. It means that addition is associative in nature. Why so? Because in case of the rational numbers, in case of the addition, they are following this particular property, or they are following this particular condition. So whenever any three rational numbers under addition will satisfy this particular condition, it means that addition is associative in nature. So you can see over here, with the help of this example, I have shown that addition is associative. I hope this all clears to you. Let's just move on further towards subtraction. So again, we'll take any particular three rational number and we'll do the same thing again with the subtraction, in which we will show that a minus b minus c is nothing but is equal to a minus b minus c. So if any three rational numbers will satisfy this particular condition, it means that they are following the associative property, or they are following the associative property. If they won't be able to satisfy this particular condition, it means that the subtraction should not be associative in nature for the rational. So let us suppose I'll take any three rational numbers again. So let if I'm taking 1 by 3, 1 by 5, and let us suppose I'm taking 1 by 4. So 1 by 3 minus of 1 by 4 minus of 1 by 5. This is my first case in which I am taking 1 by 4 and 1 by 5 within the bracket first, and again for the second case I will take 1 by 3 and 1 by 4 in the same bracket and 1 by 5 outside. So let us suppose I'll solve this particular case first. So this is nothing but 1 by 3 minus of the LCM of 4 and 5 is nothing but 20. So it is 5 minus of 4. So this is nothing but 1 by 3 minus of 5 minus 4 is nothing but 1. So 1 by 20. Okay. So further this is 1 by 3 minus of 1 by 20. Now we have to take the LCM of 3 and 20. So let us suppose I'm taking the LCM of 3 and 20 over here. So this is 3. This is 20. So this is 3 1s are 3, 20. So 5 4s are 20. Let us suppose I'm taking 5 over here. So 4 1s are 4. So the LCM of 20 is nothing but 20 into 3, which is nothing but 60. So the LCM of 3 and 20 is nothing but 60. So 3 and 20's LCM is nothing but 60. So this is 3 into 20, that is 60 minus of 3. So this is nothing but 17 divided by 60. So for the first case, I'm having the answer or the conclusion of the first case is that the value of 1 by 3 minus 1 by 4 minus 1 by 5 is nothing but 17 by 60. So this is my first case. So let's just take the second case. In the second case, we will take 1 by 3 and 1 by 4 in the same bracket and 1 by 5 outside. So let's just solve it. This is nothing but 1 by 3 minus 1 by 4. So the LCM of 3 and 4 is nothing but 12. So this is nothing but 4 minus of 3 minus of 1 by 5. So this is nothing but 1 by 12 minus of 1 by 5. Again, the LCM of 12 and 5 is nothing but 60. You can take the LCM of 5 and 12 and the answer is nothing but 60. So this is 60. And hence this is nothing but 12 and this is 60. So this is 5 minus of 12. So the answer is nothing but minus of 7 divided by 60. Now what is the conclusion at the end that we are getting? The conclusion is that A minus B minus C is not equal to A minus B minus C, because for the two cases we are getting the different answers, because in the first case case we are getting the different answer, and then the second case we are also getting the different answer, it means that a minus b minus c can never be is equal to a minus b minus of c. It means that for the case of the subtraction in the rational numbers, it is not associative in nature, because both of the answers are different to each other. It means that subtraction is not associative. So you can take any particular example. It is not mandatory that you have to take only 3 rational numbers that I have taken. You can take any particular 3 rational numbers, whatever you want. The answer will always be the same, that subtraction is not associative in nature. Let's just move on further. Let's talk about multiplication. So for the case of multiplication, let us suppose I'm taking again 3 particular rational numbers, and that are nothing but half. Let us suppose half 1 by 3 and again 2 by 3. Let us suppose. So I'm taking particular rational numbers which are half 1 by 3 and 2 by 3. Let us suppose we have to show that the condition is we have to show that a into b into c is nothing but is equal to a into b into c. So for the case of multiplication, we have to show a into b into c is nothing but is equal to a into b in the first bracket into c again. So I'm taking an example of half into 1 by 3 into 2 by 3. So let us suppose I'm taking 1 by 3 and 2 by 3 into the first bracket first, and for the second case I am taking half into 1 by 3 in the first bracket and 2 by 3 outside. So we have to show that both of them are equal to each other. Let us suppose this is my first case and this is my second case. We have to show both of them are equal to each other as per this particular condition. So let's just solve this. We get the answer as half into, first of all we'll solve the bracket as 2 1s are 2 and 3 3s are 9. So when we'll solve this particular bracket, we'll get the answer as half into 2 by 9. So we can see over here that 2 and 2 will get cancelled with each other. Why? So because 2 is in the numerator and 2 is also available in the denominator. So 2 1s are 2. We'll get the answer as nothing but 1 by 9 after cancellation. So for the second case, let us suppose I'm solving half and 1 by 3. So this is nothing but half into 1 by 3 means 1 get multiplied with 1. So this is 1 divided by 2 into 3 is nothing but 6 into 2 by 3. So again for this case, we have 2 in the numerator and 6 in the denominator. So it means that we can cancel 2 and 6 as 2 1s are 2, 2 3s is 6. So this is 1 by 3 into 1 by 3 and the answer is nothing but 1 by 9. So hence, what is the conclusion over here? The conclusion is that for the first case, we are also getting the answer as 1 by 9, and for the second case, we are also getting the answer as 1 by 9, which means that this particular property or this particular condition holds, which means that the rationals are multiplication, or the rational in case of the multiplication, they are nothing but associative in nature. As per this particular condition, multiplication is associative for the rational numbers. As per this particular example we have seen, we have concluded that if we'll take any 3 rational numbers a, b and c, they are satisfying this particular condition, which shows that multiplication is associative in nature. So let's just move on further towards the case of the division, and for the case of the division, we have to show that whether the 3 rational numbers, they are associative in nature for the case of division or not. So we have to show that the 3 rational numbers should satisfy this particular condition, that is a divide b divide c is nothing but is equal to a divide b divide c. So this is the necessary condition. If the 3 rational numbers should satisfy this particular condition, it means that the 3 rational numbers are associative for the case of division. If they won't be able to satisfy this particular condition, it means that they are not associative. So let us suppose I'm taking any 3 rational numbers as 1 by 2, 1 by 3 and 2. As we know that 2 is an integer, but 2 is also a rational number. So for the first case, I am taking 1 by 2 divide 1 by 3 divide 2, and for the second case, I am taking 1 by 2 divide 1 by 3 in the first bracket bracket and 2 at the end. So let's just solve this particular first condition first, which is nothing but half divide. So half divide, let's just solve this particular bracket first, in which we have 1 by 3 in the numerator and 2 in the denominator. So this is nothing but half divide 1 by 3 by 2 means 1 by 6, because 3 will get multiplied with this 2. So 3 2s is 6. So 1 by 2 divide 1 by 6 means half in the numerator, 1 by 6 in the denominator. So 6 will be in the numerator, 2 will be in the denominator, 2 3s is 6. So the answer is nothing but 3. So for the first case, I'm getting the answer is 3. So let's just solve the second case. What will be the answer for this? So this is nothing but 1 by 2 in the numerator, 1 by 3 in the denominator for the first bracket, divide by 2. So this is nothing but 1 by 2 and 1 by 3. 3 will be in the numerator after solving it and 2 will be in the denominator. So this is 3 by 2 divided by 2. So this is nothing but 3 by 2 in the numerator and 2 in the denominator. 2 and 2 will get multiplied with each other. So the answer is nothing but 3 by 4. So what is the conclusion that we are getting from these two answers, that is from 3 and from 3 by 4? That is, the first case is not equal to the second case. It means that A divide B divide C is not equal to A divide B divide C, which means that the division is not associative in nature, because we are getting the different answers from the case 1 and from the case 2. It means that division is not associative for the case of the rational numbers. So at the end, what is the conclusion? The conclusion is that addition is associative, multiplication is associative, but the subtraction and the division is not associative for the case of rational numbers. So let's just summarize the whole concept of associativity as, first of all, we'll see whether the associative property holds for the whole numbers, integers, rational numbers for the case of the 4 basic operation: addition, subtraction, multiplication and division, yes or no. So let's just start with the whole numbers first, as we know that for the case of the addition, whole numbers are nothing but associative in nature. So yes, the whole numbers in case of the addition is associative. Let's just move on towards the subtraction. Whether for the whole numbers associative property holds in the case of subtraction? No, definitely. For the case of multiplication, yes, because we know that A into B into C is nothing but is equal to A into B into C in case of the whole numbers. Let's just move on towards the division. So the answer is nothing but no. Yes, the whole numbers are not associative in case for the division. Let's just move on further towards the integer. For the case of the addition, answer is yes or no. So the answer is yes, because A plus B plus C is equal to A plus B plus C. When we'll solve both the cases, we'll get the answer that the associative property particularly holds for the integer. Let's just move on toward the subtraction. The answer is nothing but no. For the multiplication, the answer is yes. For the division, the answer is no. Definitely. Let's just move on further towards the rational number. For the first case, for the case of addition, they are associative. Yes, they are associative. For the case of subtraction, they are associative. No, they are not associative for the case of subtraction. For the case of multiplication, yes, they are associative. For the case of division, no, they are not associative in nature. So this is all about the associativity for the whole numbers, integers, rational numbers in case of all these basic 4 operations.